Till now we have discussed DC generators. Now we are going to discuss DC motors. Now just as a sort of revision, what is meant by DC generator and DC motor? There is going to be the same structure, whether it is a DC generator or it is a DC motor. In a generator, what is going to happen? You are going to give the rotation, you are going to turn the rotor, and there is going to be a field flux. This is common. The field flux is going to be present and the rotation is going to be present. In response to this, there is going to be a induced voltage, and this induced voltage is going to generate current when a load is connected. This is generator. And what happens in motor? Here the field flux is common, but here there is going to be a voltage that is given. Voltage is the input here. And in response to this voltage input, when voltage is input, then current is going to flow in these armature conductors. And in response to this current and this field flux, there is going to be rotation. So that is the DC motor. Next, classification. So the DC motor and DC generators, they are all classified in a same way, separately excited and self-excited. Okay. Now what is separately excited? The circuit diagram if you draw, the field winding is going to be excited by a separate DC source and the armature is going to be a separate circuit. Okay. And in case of a motor, what the field current, anyways it is going to be same. If this is the field, the supply, then the field current will flow like this. Then what about the armature current? Here we are inputting, we are giving the input, electrical input. So current, armature current will flow into the rotor. In generator what happened? The armature current was flowing out of the armature. Okay. And as it is, there is going to be an internally generated voltage and there is going to be a armature resistance. This is the supply voltage V. Okay. This is what separately excited. Similarly, you can draw for everything else. Self-excited, if you take the shunt, then how it is going to be? The armature is going to be like this and the field winding is going to be in parallel. Then the armature current direction is into the armature. This is the field current and this is the supply current. You can write as IS, and this is the voltage V. This is the shunt connection. Okay. In self-excited, it is a shunt connected motor. Next, what about series motor? In the series motor, the field winding is going to be in series with the armature, and this is going to be the armature current, field current as well as the source current, and the given voltage we can write as V. This is what? Series motor. And then you can finally draw the compound motor. Compound motor, again you have the long shunt and short shunt, right? So in long shunt there is going to be a series winding and the parallel winding will be across the entire branch. Okay. So here again this is IA, this is IS, and this we can write ISH to differentiate between the shunt and field winding. And what about short shunt? In short shunt there is going to be a shunt winding like this and series winding is going to be like this. Okay. So this is the long shunt compound motor and this is the short shunt compound motor. Okay. So this is the classification. Next, here the generated voltage in the motor, it is called as back EMF. So why it is called as back EMF? See, the basic principle is going to be the same. Whether it is a DC generator or it is a DC motor, there is going to be an induced EMF in the armature. Okay. But in case of a DC motor, what is going to happen? You are going to supply a voltage, right? And because of this supply voltage, what is going to happen? There is going to be current in the armature coil. So you have a supply voltage which is making the current flow in the armature. So we have armature current. This is just like there is a winding here, this is the armature coil, let us say, and then we are giving a voltage to it. Okay, so current will flow obviously. Now what is going to happen, there is going to be an induced voltage, because the armature windings, they are nothing like, you can consider it like a coil. Okay, they are inductive in nature. So there will be some voltage induced in opposition to this supply voltage, and that induced EMF is what we call as the generated voltage. In the generator you write as EG, in the motor you often write it as EB, calling the back EMF because this EMF is opposing this supply voltage. That's why the name back EMF. So you can write here, when a DC motor is given a DC voltage, then voltage is induced in the armature coil such that it opposes the supply voltage. The supply voltage is nothing but the cause. This is the cause. Okay, and because of this it is called as back EMF. Okay, and what do we denote it as? EB. Here also you can write EB. Now the significance of back EMF is that the amount of work that is done by this external source against this back EMF, that is equal to the work that is required to rotate the motor. That means you can write the mechanical power developed is equal to the back EMF into the armature current. So if there is no back EMF, then there is not going to be any mechanical power. There is going to be torque only if there is a back EMF. Okay.